All right, today we're going to be looking at the amplitude, thinking about that word amplitude and how it applies to actual sine and cosine functions. So the amplitude, and we've mentioned this in the previous video, is the distance between that middle line that cuts one of these functions in half. We called that, when we were talking about sinusoidal functions, we called that the sinusoidal axis. Okay, so now this could be a cosine function or a sine function, but think about the amplitude as the distance between the sinusoidal axis and either the top crest or the bottom crest. That is the amplitude. So when we're thinking about a sine function, y equals sine x, well, the amplitude is naturally going to be 1. If we graph a regular sine function, notice this blue is the regular sine function, the height is at 1 and the lower height is also at 1. The normal is 1 unit away from the sinusoidal axis. And that kind of makes sense because when we think about the unit circle, we think about that distance of 1. So 1 is a number that, okay, that makes sense. Now, notice how it is a 1 as an understood leading coefficient to our sine x. So when we change that, if we change it to a 2, or if we change it to a 0.5, that is directly affecting our amplitude. If it is 2 sine x, well, you guessed it, the amplitude is going to be 2. Notice that the height of that red function goes all the way up to 2, goes all the way down to -2, and the same thing for the green function. If it is a half, well, the amplitude is now decreased. It is only going up by a half and down by a half from the sinusoidal axis. So let's see how this plays out. Here it says, describe how the graphs of sine of x and 1/4 sine of x are related. Then find the amplitude of g of x and sketch the two periods of both functions on the same coordinate axis. Well, we already know some things. All right, we know the amplitude of this first one, the amp is 1, and the amplitude of this one, the amp, is a 4th. We know that. We can see that. And how are they going to be related? Well, think about what's happening if we start at 1 and then it kind of shrinks to 1/4. It is 1 distance. Here's our sinusoidal axis. It was 1 unit away. Now it's only going to be 1/4 of a unit away. Well, remember back when we talked about function transformations, that is a vertical compression by a factor of 1/4. All of the outputs that we would have had here are then being multiplied by 1/4. So this is going to be a vertical compression by a factor of 1/4. So, a little help from my friends. AnalyzeMath.com. There is a sine function. Y equals sine x. Just went ahead and threw it down on there. Now, we are dealing with radians here. Sine of 0 is 0. Sine of pi is 0. Sine of 2 pi is 0. In the meantime, sine of pi over 2 is 1. Sine of 3 pi over 2 is -1. Those are all facts we know from the unit circle. Even the intermediate values, we know sine of pi over 6, which is somewhere about right here, sine of pi over 6 is a half. So that makes sense. Sine of pi over 4 would be root 2 over 2. Sine of pi over 3 would be square root of 3 over 2. And so those values build our sine function. We're dealing with radians here. So there's our sine function. What do we expect? Our vertical compression. How are we going to get a vertical compression by a factor of a fourth? Well, all of our outputs are then multiplied by a fourth. Instead of at pi over 2 getting out a 1, we get out a 1/4. We still get out a 0 when we have zeros. At 3 pi over 2, we get out a fourth now. Get out a fourth. Over here, we get out a fourth. In between, we get out, instead of a half, a fourth of a half is an eighth. So when we connect these, we still have that same function. It's still going to continue in both directions, but all the outputs have been compressed. It is a vertical compression by a half here. So very similar. Notice here it says describe how the graphs of cosine of x and -3 cosine of x are related. And we know so much about functions, so think about what's going to happen. We already have talked about that number on the outside is declaring the amplitude. Well, it's actually the absolute value of that number that declares the amplitude. So instead of an amplitude of 1, this is going to have an amplitude of 3, not -3. We can have an amplitude of a negative because that's the distance away, negative distance. No. The absolute value of that number, 3, will be our amplitude. So the amplitude here is 3. Now what does that negative do? Think about it, think about it, think about it. That negative is going to reflect it across the x-axis. Just like always, whenever we put a negative out in front of that function, it's going to reflect that function across the x-axis. So we can go ahead and, well, we notice the amplitude. We want to know how they're related. This is going to have a vertical stretch by a factor of 3. And it's going to be reflected across the x-axis. Yeah, so there we go. There's our cosine of x function. Notice it's in radians. Cosine of 0 is 1. Cosine of pi over 2, 0. Cosine of pi, -1. This is just our facts from the unit circle being placed and noticing the oscillation of here. So here's our first graph. Here's cosine of x. Now, -3 cosine of x means our outputs are going to be multiplied by 3, and it's going to be reflected. All right, so instead of 1, it's 3, but then it's reflected, so way down here at -3 would be our point. And it's a giant graph, so you have to bear with me. It's reflected, and we have multiplied that output by 3. When we multiply -1 by a -3, we get out a +3. That would be way the heck up here. So you can see this one would then be way the heck down here, and so on. So we have, that point would be way up here. Not the best drawing ever done. We're still going to have those outputs at 0, because 0 times -3 would remain the same. That wasn't lined up very well. And so it's going to continue this oscillation, but it has been reflected and it has been stretched out. All right, so this is gigantic. That's what's happening.